We are demonstrating a project that is design and implementation of battery charging circuit using a solar panel with a power rating of about 40 watts in ideal conditions. The open circuit voltage is about 22.32 volts. The short circuit current is 2.42 amperes. The rated voltage and current are 18.1 volts and 2.21 amperes respectively. The output of this panel, that is the two terminals you can see, serve as an input to the boost converter.
The output of the panel is given to the boost converter, and in boost converter we have an inductor over there, and after the inductor in parallel we have a MOSFET, and in series we have a diode, and in parallel we have a capacitor, and we have connected two batteries again of 12 volt each, which will be charged at 26 volts. For the switching of MOSFET we have used an Arduino. The Arduino is used for MOSFETing signal. The MOSFETing signal is done by the help of these two inputs of the two inputs coming from the panel, as we have used a circuit of two resistors, and these resistors voltage will be given to the Arduino, and the Arduino will give a signal that will give gate signal to the MOSFET, and it will be done a gating signal to the MOSFET, and the MOSFET will work as a switching element. And after that we have two batteries. We will find the SOC of the battery with the help of our Arduino. We have again implemented the same system as we have done before. We have two resistors and in series, and the output from one of the resistors is given to the Arduino. That Arduino gives signals to the LCD, and the LCD will display the output like we can show over here. The voltages of the two batteries will be shown in this LCD after this only. The voltage is shown over here, that is 73.79 volts.
A PowerPoint presentation of our Capstone project named as the design and implementation of the battery charging circuit using PV module. The PV module is nothing but the solar PV system which uses the cells to convert the sunlight into electricity, and that is exactly of the semiconductor layer made upon usually of the silicon. So moving on, next slide is introduction. So the main challenge with the solar is the high cost of the photovoltaic system and the direct dependency on the sunlight intensity. So our project concentrate on the solar power system to be used to power different devices by storing it in a battery for the later use. So the photovoltaic cell based batteries charging system is being designed in this project, and the PV module that I explain later is just the interference that provides an appropriate voltage to the charging rechargeable battery, which is called as a PV battery charger. And moving on to the next slide, a need analysis. So the design and implementation of the battery charging using this PV module is the electrical design parameter, and the we uses this analysis algorithms. So performance analysis of the system need to be carried out to the difference between the simulated data and the recorded data. Yeah. And moving on the next slide, we have used these three objectives to study. The first one is to study the construction unit of the lithium ion battery, and the second one is that to study and design the charging circuit of the using this PV voltaic cell, and the third one is that to determine the state of the charging SOC of the battery using this microcontroller. We have used Arduino in our project. Okay. And deliverables that we use are the charger will be using this PV cells output to charge the battery efficiently. The maximum available amount of the sunlight in any weather condition get converted DC current from the PV cells and charge the battery. And the state SOC, that is the state of the charging method capable of determining the charging state of the battery with a great wishes. Moving on to our next slide is the working principle. You can see that the main part is the boost converter, which is the inductor. Okay, the inductor property of not letting the current to change instant is what is something that boosts the voltage, and we have found the value of the capacitor and the inductor using this formula that you can see: I naught into d upon fs into delta v naught, and L is equal to v into d by fs into delta I naught. So next slide is our assumptions and the constant. So we have these assumptions, which is the voltage fluctuation is very less, and the second one is that it is assumed that the battery is charged at the constant speed, so and no battery losses are there. And these are the constraint in this project: slow charging, less charging efficiency, and the battery will not charge fully because of the inverter circuit. A square wave is the output, and it charge the battery but with a less efficiency, so the battery charging efficiency is less. And sometimes we also have these weather problems, so which is also being affected in moving on to our next slide. These are the technical standard that we used in this our project. You can see that these are the standard we have used. Moving on to the next slide is that the method that we used is that the okay, now this is the method that we have used in this. Okay, we have this the charger that will charge for the preset limited time and stop for the limited time, and the repeat until the charging is completed. And we have this use this all algorithm. The goal of this algorithm is to obtain the maximum solar power which is available from the PV array. Okay, solar power which is being converted to used to charge the battery voltage, and input power is calculated based upon the measured input voltage and current. Our algorithms keeps trying to achieve the maximum output power. Okay, these our calculation continues attempting the new current set point to guarantee the maximum access sunlight based upon the base power to be is accomplished. This is our functional block diagram. We have first start and then check the voltage across the panel, and then the MOSFET will be switched so that the output of convert is constant at 26 volt. Next is that the output is connected to the battery, and then battery is connected to the Arduino. The Arduino connected to the LCD which will display the voltage across the battery. And moving on our next, these are the simulations and hardware result. So you can see these are the battery charging characteristics, battery voltage, battery current. These are its output around the LCD panel that we have get. So finally the conclusion.